Okay. So in this video for 4.4, chapter 4, section 4, we're looking at solving quadratics. So right now we're used to graphing, and then we kind of re-talked about how to write quadratic equations. You normally have this a in front of the x squared, and then you have a b in front of x, and you have a c at the end. So you have ax squared plus bx plus c. So here's my b is 4, my c is 1, and this one my x is 1. So in this section, what we're going to do is we're going to talk about solving quadratics. So now we have a normal just quadratic equation or quadratic function. All right, so to practice, you can go ahead and graph these, plug in, you can make tables if you want, plug in x's, and maybe do some negatives as well, and then find the y's, right? That's one way to do it. Another way is to find the vertex. So first you have to find the x value, which is the opposite of my b, and then divide that by 2 times my a. And then once I have an x value, you can plug it in for your x's and solve for your y's. That's why it's y equals. Okay, so you can go ahead and do those ones. So this could warm up and get ready for solving, because the first thing we're going to do in section 4.4 when we solve is we're going to solve it by graphing. And what we're looking for here is we're looking to answer basically this question, kind of how many times does it cross the x-axis? So if this is the x-axis, a better line than that, but that's okay. And here's the y-axis. What we're looking for is when we solve these, so I might have a graph that looks maybe something like that, or something like this, or maybe something like this, or something like this. Okay, so when I say how many times does it cross the x-axis, that means like these would be crossing the x-axis, these would be, oops, down here, and this would be, this one right up here doesn't cross the x-axis. So what we're looking for when we're solving these, we're looking for what is the x value that makes my y value 0. So like for this point, the y value is 0. 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 For this one, it's 0. This graph, I don't have an x value that when I plug it in, I will get y equals 0, because it doesn't cross the x-axis at all. Because remember, all the points along the x-axis, all these values for y are y equals 0, right? Because this would be 1, y1, 1, y2, y3, y4, y5, or negative 1 for y, negative 2 for y. So when we're solving these, we want to know where does it cross the x-axis, meaning where on my x's is my y value 0. So that's what we're looking for. So that's why what we're going to do here, a lot of times what you'll see from the very beginning is all the y values will be 0. So these would just be like having zeros, because that's what we want. We want our y to be 0, and we're solving for the x that makes our y value 0. So you can go ahead and graph these, because that's our first thing for this section, is to graph quadratics and look for where does it cross the x-axis, at what x value does it cross the x, or the x-axis. So normally in a quadratic equation, we can write set equal to 0 like I just talked about. And so that's a standard form when it's set equal to 0, because normally it's just set equal to y. But we're going to have to set it equal to 0 because we want our y to be 0. Okay, and so it's just like one way to solve them is letting this 0 just be y, because that's what we want. And then we just graph them just like we have been graphing. And so what we're looking for is we're looking for those what we call x-intercepts, where it cross the x-axis, right here. And we also call those, they have some different names, they're also called roots. So you want to pay attention to these different names because they can be interchangeable. So we have x-intercepts, because that's where they cross the x-intercept, x-axis, sorry. They're also called zeros, or they're also called solutions. So all 4 of these words are interchangeable. So when we look for the answers of these quadratic equations, we're looking for those x-intercepts, the solutions, the roots, and we'll explain a little bit where you get the roots from, and zeros because y equals 0. That's why they called zeros. All right, so here's first example. So we want to solve by graphing. So we're just going to switch this 0 to y. So y equals x squared minus 1. And then we're going to graph it the same way. We can always start plugging in values, and we're looking for where we get y's of 0. So we can start plugging those in and seeing if we can find a y of 0. Or we can think about it, maybe think about what x's I might plug in. I could plug in 0, I get -1. I could plug in 2, and I get 3, right? So you can kind of look at this equation and think about where can you get a y of 0. Or we can find the vertex by first finding this x value. So opposite of b here, our opposite of b would be 0, because there is no just plain x. So we have our a and we have our b. A is 1, b is, or sorry, not b. Ooh, that it would be our c. It's our constant, it doesn't have an x next to it. So our b is 0, opposite of 0 is still 0, and 2 times 1 is still just 2. So x value of our vertex would be 0 over 2, which is the same as just 0. And I can plug that in, so, and I get -1, I already did that, because 0 squared is still 0, and 0 minus 1 is -1. And so then I have this vertex here. So there's my vertex, so I could graph that, 0, -1. And then once I plot that, I could plug in another one, like 2, 3, so over 2 and up 3. And then if I plugged in a -2, I get that same answer. So -2, 3. And then I can go ahead and graph it, and then I can maybe see, oh, let's look at this graph. It's not precise, but I can look at it and say, okay, maybe it crosses somewhere in between 1 and 2. But on this graph, it looks like it's at -1, right? And again, my graphs are not that great, but somewhere it's probably in between there. So then I can say, okay, well, let's just try -1. So let's take -1 as our x, and let's try to get 0 for our y. So if I plug in -1, square it, I get 1, and 1 minus 1 is 0. So my y is 0. So at -1, I get a 0 for my y. So my x-intercept is x equals -1, because when I plug in -1, I get 0 for y. Here you can do this one. Try that one. And here you can think about it. What x do you plug in that you would get 0 for y? So you can think about that. You could graph it. Plug in a number, we get 0, 0. Plug in 1, we get 1. Plug in -1, we get 1. So here's our graph. So we're looking at the graph for our answer, and our answer for this of a graph is where it crosses the y-intercept, and that is at that x value of 0. So at x equals 0, it crosses the x-axis. So there's our solution. So our solutions are where it crosses the x-axis, which are called x-intercepts. So you can go ahead and pause the video and try this one. You can graph it, and then look at your graph. Where does it cross the x-axis? Right, and look for those x values, whatever they might be. Okay, so we're looking for where, when we plug in certain x's, our y is 0. Okay, solving by square roots. So here's a different way to solve it without having to graph. So we're going to solve by square roots. That's why these are called roots, because a quadratic is an x squared, basically. And we can get rid of squared by square rooting. So that's why our solutions are also called roots. So how you do this is, first, you're going to make sure that there is no b. Sure, b equals 0. So that means no plane x's, right? So there's not, normally it's ax squared, bx plus c. So this is gone, there's no just plain x's. So that's true. And then 2, we can just move c to the other side. Move c and a to opposite sides by doing the opposite. So moving the opposite sides of the equal sign. So here on this equation, I'm just going to add 75 to both sides. So now my A and my C are on opposite sides of the equal sign. And then 3, I'm going to divide by A, divide both sides by A. Oops, both sides by A. So I do that. So I have 3x squared equals 75. I divide both sides by 3 because that's my A, and I get x squared equals 25. Then the fourth step is to take the square root of both sides. So I have x squared equals 25. And I'm going to square root both sides. So the square root of x squared is x. Square root of 25 is 5, positive 5. And it is negative 5. So there's my two answers. So what my graph would look like as that negative 5 and positive 5, my graph would cross right there. So that's what it would look like on the graph. And here's what it looks like by solving by square roots. So those are the answers that we want. Those will give us a y value of 0. Okay, so that's how we solve by square roots. Okay, go ahead and pause this one. You can try this one. And, oh, another thing that you can do is you can check your answers. So number 5, check. Anytime you have an equation, you can check. So I can plug 5 and negative 5 back in. So 5 squared is 25, times 3 is 75. 75 minus 75 is 0. So I checked it. Now I do negative 5. Negative 5 squared is still 25. 25 times 3 is 75. 75 minus 5, 75 is 0. So go ahead and try this one and go ahead and check your work. You're looking for what can you plug in for m that will get you an answer of 0 here, right? That when you subtract 36, you get 0. Okay, some word problems. You can go ahead and read through this. We're looking for a reasonable solution, right? So here we have a fish tank, and we know the length is twice the width, so our length equals 2 times our width. We know the volume, which volume of a rectangular prism here is length times width times height. And we know that volume is 420. And we know our length is 2 times our width, so this length is also 2 times our width. Okay, and then W times W is W squared. Oops, we got the 2 out front. And times H. So now I can go ahead and solve, and they give me some more information. So what I'm trying to solve for is W. What is the width, right? What is the width of the tank to the nearest foot? Okay, so that means I have two variables, W and H. So that means they have to give me H if they want me to solve for the width, if they want to solve to W, which they don't give it in the words here, but they do give it in the diagram. It's 3. So I'm plug in 3 for that. So this is all multiplication in between here. So we could actually multiply 2 times 3 there and get 6W squared. And then we want to get W squared by itself. So here we don't need to add C or move C to the other side because it's already moved to the other side for us. Like so on the last problem, we had this where set equals 0 and we moved this C. But on this problem, if we were looking for A, B, and C, our C would be already moved over to the other side, right? So here you just want to divide by our A, divide by 6, so that's 70, and then we can go ahead and square root both sides. So we square root both sides, and we get a plus or minus when we square root, right? Positive square root of 70 and negative square root of 70. The negative's not going to matter because length can't be negative. So I'm going to square root 70 on my calculator. see what it is. It's probably somewhere between square root 64 and square root 81, right? So it's somewhere in between uh, 8 and somewhere in between 9. So it is 8.36. So it's 8.36 and it says round to the nearest tenth of a foot. 8.36, so we're going to go 8.4. So the width is 8.4 feet. So that's our width, 8.4 feet. So there it is. And we can go ahead and check that. We can plug it back in. But of course, we're too lazy, and I'm kind of too lazy. But I can let you go ahead and do that. Okay, so here's the same example. This time you have a height of 4. So there's your h. You have your volume of 500. And then again, you want to the nearest foot, the width to the nearest foot. And you know, again, the length is twice the width. So same exact thing, except for instead of 420, it's 500. Instead of 3 feet, it's 4 feet. So go ahead and try to solve that. All right, and that's it for 4.4. So it's not too much. It's just solved by graphing. It's a little bit harder. So you can keep on plugging in x's, maybe some negatives, and see kind of what you get. And what you're looking for is a 0 for your y. Okay. Or you can graph that vertex first. So first, take the opposite of b, times it by 2a, or take the opposite of b and divide it by 2 times your a, and then plug that x in to see what your y is, and then kind of go ahead and graph it. Maybe your point's right here. There's your vertex. You can go ahead and draw it up, and then kind of estimate what this might be, and then you can start plugging in x's that look close to those. But unless you have graph paper, you're going to have to estimate maybe what this is, and then so maybe that looks between like 2 and 3. And so you're going to go, okay, maybe I'll try 2, or maybe I'll try 3. Okay, so that's how you do it by graphing. And then solving by square root, we got to make sure there's no b equals 0. And then we can move our c, divide by our a, and square root both sides. And when you square root, you always get a plus or minus, unless you have word problems like this where you're looking at length, and length all you care about is the positive. Okay, so that it is. It's done.